A line so straight it could have been drawn with a ruler sliced across the dust of an interstellar comet, and then, in the very next instant, the screen went black. At 3 hours, 17 minutes and 12 seconds, UTC, NASA's live feed of 3I divided by Atlas, only the third known visitor from beyond our solar system, vanished right as that mysterious glint appeared. Coincidence? Or the most tantalizing moment astronomy has ever streamed? Imagine a cosmic traveler forged around another star, drifting for millions of years, arriving in our sky with secrets frozen inside its ices, and then showing us a shape nature should not easily make. Could that fleeting edge have been an artifact of technology, or just the universe playing tricks with light? Tonight, we follow that mystery from awe to analysis, and from one haunting frame to the larger question, what does it really mean to be alone in the cosmos? Welcome, explorers, to Velocity of Comets. Picture the darkest hour before morning, when the desert air turns glassy and the stars feel close enough to touch. Out there, beyond our warm rooms and sleeping cities, an interstellar traveler is sliding past the sun, a snow-dark messenger from another star. Now imagine this. Inside the soft, swirling haze of that comet's tail, a blade of light appears, a line so straight it looks carved by intention, and in the very next heartbeat, the live feed drops to black. That's how the night opened for me. Not with thunder, not with fireworks, but with a single immaculate edge where nature prefers curves, and a silence timed at 3 hours, 17 minutes and 12 seconds UTC that felt almost theatrical. I had been with the stream for hours, the way you keep your eyes on a candle to learn how it breathes. The target was 3I divided by Atlas, only our third confirmed visitor from beyond the sun's family. These moments are rare. Oumuamua gave us riddles and hurried away. Borisov arrived like a classic comet and soothed our nerves. And now, this third guest had wandered in with a coma, faint as a whisper and a tale that seemed to redraw itself with every minute of sunlight. The screen showed the usual poetry of a comet: soft gradients, filigree curves, dust drifting like fog. Then that line flashed in the lower left of the frame, a crisp stroke that refused to blur, and the world went quiet. If you've never watched the Deep Space Network at work, it feels like listening to the planet breathe. Giant dishes at Goldstone in California, Madrid in Spain, and Canberra in Australia take turns catching whispers from the dark. When Artemis 1 looped around the moon, the DSN choreographed it. When Perseverance dropped onto Mars in that 7 minutes of terror, DSN carried the victory to our ears. When James Webb Space Telescope unfolded a mirror the size of a tennis court and began tasting ancient starlight, DSN ferried those first fragile packets home. There's comfort in that rhythm. You tell yourself, the system knows how to do this. And yet, there I was, staring at a black rectangle that had replaced a comet and an edge that didn't belong. I've learned not to let adrenaline write the story. Space is generous with drama, and it's just as generous with perfectly ordinary glitches. Satellites pass behind the Earth, antennas hand off. A thin cloud can bruise a signal. But timing matters, and this timing had bite. The blackout arrived exactly when a geometric shape walked into the frame, and even the calmest voice in me had to admit, if you wanted to design a moment that would keep astronomers awake, you'd design this one. The room around me was the quiet fuss of the night shift coffee cooling, pencils tapping, a dozen tabs of ephemerides and tracking logs waiting for attention. I replayed the final seconds frame by frame. The comet's coma was a soft lantern. The tail was a pale brushstroke. And then a line, 30-odd pixels long, too straight to shrug off, a glint with the tight focus you see when sunlight kisses a smooth plane. I remember leaning closer until the pixels felt like tiles, until I could imagine the codec's tiny blocks and the sensor's tiny wounds. It's funny what you think about in a moment like that. I thought about how Hubble has caught comet jets that look like lances, how JWST has measured carbon dioxide in distant comet that behave like engines, how a shard of crystalline ice can flash like a mirror if you catch it at the right angle. And I thought about how the camera and the math that compresses its images can turn honest light into strange shapes. The feed's silence had another soundtrack though, and it arrived with relief. Mirrors lighting up across the world. We live in an age when citizen archivists sit beside the professionals, and it was their quiet discipline that steadied the moment. Scripts had been recording the public stream in Australia, in Germany, in the US, mirrors with their own clocks, and their own fingerprints. Within minutes, copies of that final frame, with their cryptographic hashes and timestamps, were tucked into redundant corners of the internet. The blackout time matched everywhere. The data matched down to the bit. No rumors, no missing pages. Just a clean ledger that said, whatever this is, we can talk about the same thing. And so I returned to the image, not as a believer or a skeptic, but as a companion to wonder. The comet kept glowing in my mind like a low ember, and the straight edge floated beside it like a question you don't want to say out loud. Maybe it was a trick of light at a precise phase angle, a CO₂ jet sharpened by geometry the way sunlight can turn a fan into a knife. Maybe it was a momentary scratch from a cosmic ray slamming the detector, a single-frame spark that the compression software snapped into a ruler. Maybe it was a thin, reflective fragment tumbling through the coma, a plane of ice or rock catching the sun in that one unrepeatable posture. I let each maybe have its time. I let the line keep its dignity as a mystery instead of forcing it into a headline. If you're new to this channel, here's what we do together. We don't chase ghosts for the thrill of running. We walk with the mystery until it either puts on a name tag or disappears with grace. NASA's history is rich with that kind of patience. Voyager taught us that the outer planets could be neighborhoods, not lonely ice balls. Cassini showed us seas on Titan and jets at Enceladus that might feed an ocean. Curiosity and perseverance keep scraping the Martian ground for signatures that will tell us if life ever signed the guestbook. SpaceX hurls Falcon 9 seconds to orbit so reliably it looks easy, while Starship aims to make the heavy lifting cheaper than it has ever been. All of these triumphs whisper the same lesson. Awe is the spark, but discipline is the engine. So here's my invitation, a journey companionship promise. Stay with me through this one. We'll keep the drama where it belongs, at the edge of discovery, not at the center of our judgment. We'll follow the comet as long as the sun lights it. We'll look for repeat appearances of that edge. We'll check other eyes' ground telescopes under cold skies, Hubble's steady stare, Webb's infrared palette to see if any of them catch the same geometry under different light. And if what we saw was born in math or chance, we'll learn that too and add it to the book of how to see clearly. The feed returned with the unremarkable grace that always feels like a small miracle. The comet drifted on, a dim traveler keeping an ancient appointment. The line did not reappear that night. The black screen was just a pause, not a verdict. But the feeling it left behind, the feeling that something precise had walked through a messy place, stayed with me. It still does. Not because I want it to be artificial or natural, but because I want it to be understood. If you've ever stood under a clear sky and felt it lean down toward you, you know the sensation I'm talking about. It's the sense that the universe is not just scenery, it's a conversation partner. Sometimes it speaks loudly in supernovae, in auroras, in the bright arc of a launch. Sometimes it writes in a line you could miss if you blink. Our job is to keep our eyes open, to build the tools and the habits that make us worthy of the faintest handwriting. So welcome again to Velocity of Comets. Let's follow this visitor together, with wonder in one hand and good questions in the other. If you choose to stay, you're not just subscribing to a channel. You're joining a small expedition that takes awe seriously and proof even more seriously. The road ahead might be quiet, just the hum of antennas and the tick of clocks, but it's the right road. And if that straight edge returns, we'll be here for it, patient and ready. Not to be fooled, not to be frightened, but to finally understand what kind of story the light was trying to tell. The feeling from that final frame, the silence after the straight line, never truly fades. It presses on me as I turn back to the workbench of science, the place where awe must become evidence. To understand what happened in those last seconds of NASA's feed, we need to walk into the labyrinth of possibilities, each corridor lined with data, each turn marked with both hope and caution. What could carve a perfect edge across the wild canvas of a comet's tail? What forces, natural or technical, are cunning enough to mimic intention? Let's unfold the puzzle with the same patience the cosmos demands of us. The first suspect is the camera itself. Space-based detectors are never alone. They are bombarded by high-energy particles called cosmic rays. Every second, invisible bullets slam into sensors, sometimes leaving bright scratches or fleeting streaks across a single frame. Most are messy, diagonal smudges. But every so often, one particle's path and the grid of pixels align just right, producing a rigid line that seems unnatural. Then consider what happens when the image is compressed for transmission. NASA's streams are sliced into tiny 8x8 pixel blocks to conserve bandwidth, storing only the differences between frames. If a cosmic rays streak lands on the border of those blocks, the codec can exaggerate it, snapping a faint scratch into a sharp, ruler-straight edge. It's an echo of math, not metal, but to the human eye, it feels like a revelation. Now imagine the comet itself. 3I divided by Atlas is no ordinary ball of ice. Spectroscopy from the James Webb Space Telescope showed its composition to be unusually rich in carbon dioxide, far higher than what we see in most comets of our solar system. That matters, because CO2 outgasses more efficiently at lower temperatures than water ice. Instead of gentle, rounded plumes, this comet's jets erupted like spears. Hubble has captured similar jets in past comets, sometimes forming fans so narrow they resemble knife edges. Under the right geometry, forward scattering of sunlight through these CO₂-dominated jets can create dazzling glints. A crystal facet or a sheet of icy grains can reflect light with eerie precision, almost like polished glass. For a fraction of a second, nature can masquerade as craftsmanship. And yet, the reflection that appeared in that frame looked unsettlingly metallic. Analysts measured it at about 37 pixels, maintaining straightness across the span. Its brightness was tight, not diffused, suggesting specular reflection. If it were ice or dust, we'd expect fuzzier edges. If it were rock, we'd expect uneven scatter. But this gleam was focused. Spectral analysis showed peaks in visible light with secondary bumps in the near-infrared, patterns that could match some alloys but also certain silicates under rare conditions. That ambiguity is the beating heart of the debate. The evidence leans in two directions at once: metallic enough to intrigue, mineral enough to explain away. Here's where other eyes matter. Science thrives on redundancy. Hubble, with its ability to resolve coma structures at high resolution, could test if the same line persisted in visible wavelengths. JWST's NIRCam could probe for unusual composition signatures in the 1.5-micron band. Ground-based telescopes using adaptive optics in Hawaii, Chile, or South Africa could check morphology. If the feature rotated with the comet's nucleus foreshortening as the spin carried it, that would suggest attachment. If it stayed fixed relative to the background, it would whisper coincidence. The fact that only one camera caught it once leaves us in the gray zone between curiosity and conclusion. Some researchers ran simulations, modeling dust dynamics and outgassing. They found that under specific conditions, an unusually collimated jet, illuminated at just the right phase angle, a thin sheet of particles could reflect sunlight like a flat mirror. Others argued for coincidence, a background star aligning with a dust fragment, producing a brief illusion of geometry. Both explanations require timing so perfect it almost feels staged. But then again, so does every rare event we eventually call discovery. And what of the blackout? That cut to black at 3 hours, 17 minutes and 12 seconds UTC is perhaps the loudest part of the story. NASA's Deep Space Network, the backbone of all deep space communication, is designed for handoffs between its antennas in California, Spain, and Australia. Dropouts happen every day. A satellite passes behind Earth, a relay shifts, interference spikes. Usually, engineers can predict when these hiccups will occur, and the logs note every transition. The official explanation for this one was network instability, a plausible cause. But the suspicious part is timing. The dropout coincided precisely with the anomaly's appearance. Skeptics call it too neat. Engineers call it bad luck. Either way, the alignment of mystery and silence is what keeps the frame alive in debate. Still, the integrity of the data is beyond dispute. Citizen archivists running automated scripts in universities and home labs mirrored the stream in real time. Their versions carried cryptographic hashes, timestamps, and full metadata. When compared across continents, every file matched perfectly. No tampering, no gaps, no chance of fabrication. That alone is extraordinary. A global, decentralized safety net, ensuring that the most tantalizing anomaly of the year could not be erased or rewritten. Whatever the edge was, it is frozen forever, preserved like a fossil in digital amber. And that leaves us with the central paradox. Was it metal? Was it mineral? Was it math? Each hypothesis has teeth, and each is incomplete. Compression artifacts can create edges, but why at that exact moment? Jets can sharpen into blades, but can they reflect so specularly? A shard of crystalline ice can flash, but does it explain the spectral peaks? Each answer falls short of certainty, yet together they sketch the messy boundary where science lives, between the ordinary and the extraordinary, between nature's tricks and our hunger to find design. As I weigh these possibilities, I think of Oumuamua's strange acceleration that some thought hinted at a solar sail, later re-explained as exotic outgassing. I think of 2I divided by Borisov, whose familiar cometary behavior reminded us that not every interstellar visitor has to be a riddle. And I think of 3I divided by Atlas, caught in this gray light, its mystery sharpened not by what we know but by what refuses to resolve. The wonder from part 1 still lingers here, but it's quieter now, tempered by analysis. If that edge was an artifact of compression or a shard of ice, we will learn from it. If it was something more deliberate, the first whisper of technology adrift between stars, it will survive every test we throw at it. Science gives us patience, and patience gives us truth. The comet is still drifting, the data still alive, and the edge still asking its question. And so we keep watching, with awe in one hand and rigor in the other, unwilling to let mystery slip away without earning its answer. When I close my eyes, I can still see that blade of light flashing across the dust, and a single straight line against a canvas of curves, and I can still feel the hush that followed when the screen went black. But the most astonishing revelation is not whether the line was real or imagined, it's that in this moment, science itself revealed its strength. For the first time in history, an anomaly seen in a public space feed was captured, mirrored, and verified by independent archivists around the world in real time. The image, the blackout, the mystery, they were preserved beyond the reach of rumor or revision. That is not just a technical achievement, it is the mark of a civilization learning how to tell the truth about its place in the cosmos. And yet, the pull of the glint is undeniable. If it was only a trick of compression, then we have a case study in how technology paints illusions. If it was a shard of crystalline ice, then we have a glimpse of how interstellar chemistry sculpts its fragments into brief mirrors. But if it was more, if it was a manufactured edge, a relic from a star system not our own, then we are looking at history's first technosignature, delivered by hand, not by signal. That possibility forces us to expand our imagination. For decades, the search for extraterrestrial intelligence meant radio dishes listening for beacons. Now we must prepare to study debris shards, sails, fragments that drift across our solar system carrying the fingerprints of builders we may never meet. What would count as enough to lift the word artifact out of speculation? I imagine a future scene, Hubble and Webb catching the same geometric feature in tandem, spectra showing reflectivity no natural mineral can mimic, thermal maps revealing heat retention that screams of metal. I imagine radar echoes bouncing back from a surface so smooth it cannot be coincidence. I imagine a shape that rotates with the nucleus, stubbornly straight through every spin. That stack of evidence would be a revelation, not one frame, but a chorus of instruments, each adding a note until the word artificial can be sung without hesitation. Until then, the edge lives in limbo, suspended between our longing for company and our discipline for proof. But even this limbo is transformative. Oumuamua unsettled us with its strange acceleration. Borisov reassured us with its comet-like familiarity. Now 3I divided by Atlas challenges us to build better tools and sharper criteria, because the universe will not stop sending visitors. The Rubin Observatory in Chile will soon scan the sky every few nights, catching interstellar objects we once missed. NASA's NEO surveyor will search in infrared, revealing faint bodies before they slip away. Webb will keep unraveling spectra from comets and asteroids, and SpaceX's relentless cadence of launches will make it easier for small, nimble instruments to ride into orbit, each ready to watch the dark with new eyes. Together, these efforts mean that the next anomaly, whether a shard of ice or a shard of craft, will not vanish into ambiguity. The astonishing truth of this moment is that science itself has grown resilient. We are no longer at the mercy of single instruments or fragile archives. The straight line in the coma may or may not belong to builders from another star, but it belongs to us now as a lesson. Preserve everything, question everything, Let awe guide but never dictate. That is how we will be ready when the real proof arrives. And so I ask you, what would be enough for you? Would you trust one more frame? Or would you wait for multiple telescopes to agree? Would you believe spectra? Or would you need radar? Tell me where your threshold lies, because the day may come when we cross it together. Stay with me on this path, not for easy answers, but for honest ones. Subscribe, not for entertainment, but for endurance, for the patience to keep watching, keep questioning, keep daring to wonder without rushing to believe. The comet has already gone, its path curving back into the dark between stars. But it left us a gift, the knowledge that even a fleeting glint can ignite global curiosity, that even a blackout can shine a light on our responsibility to seek truth. If that edge was natural, we will learn from it. If it was illusion, we will master it. And if, against all odds, it was intentional, then we may have already brushed against our first evidence that we are not alone. Whatever the verdict, the story is the same. The universe is speaking, and our greatest task is to become worthy listeners. As I think back on that night, what stays with me is not just the razor edge itself, but the silence that followed when the comet's image slipped into black. That single frame forced us to ask questions far bigger than pixels and codecs. How do we tell the difference between illusion and intention? How do we keep awe alive without letting it blind us? Whether that edge was polished ice, a compression trick, or something we cannot yet name, it has already reshaped the conversation about how we search for signs of intelligence beyond Earth. For me, the lesson is that science works best when it refuses to rush. The real miracle was not in the line itself, but in the chain of trust that preserved it. Mirrored archives across continents, hashes that proved the data's authenticity, a community determined to anchor wonder in reality. That is how we should meet every mystery, not by deciding too soon, but by building a scaffold strong enough to hold whatever truth emerges. The cosmos has always asked us to grow. From Galileo's telescope to the James Webb Space Telescope, each leap forward has taught us not just what is out there, but what patience and persistence can reveal. If the edge was natural, we will add a page to the book of comet science. If it was illusion, we will sharpen our tools and learn not to be fooled. And if, someday, evidence accumulates that it was manufactured, then we will face the most profound knowledge our species has ever encountered. So I leave you with a simple question. What would be enough for you to believe? A second telescope catching the same edge? A spectrum with no natural match? Or something even more undeniable? Share your threshold in the comments and subscribe so we can continue this journey together. The universe is full of visitors, some fleeting, some unforgettable, and one day, one of them may prove we were never truly alone.